So question 1 in this paper, we're given the expansion of this polynomial where k is a positive constant and we're told that the term independent of x is equal to 150. So this just means that the exponent of x is 0. We're asked to find the value of k and determine the coefficient of x squared in this expansion. So what we can do here is, well, remember what the binomial formula says. So we can expand this according to the formula like n choose r. So the rth term of this is just going to be the first term to the power of n minus r, and this will be multiplied with the second term to the power of r. So what we can see here is that is what these exponents will have to be. Well, n is obviously going to be 4. That's our exponent here. That's our largest exponent over in this equation. And we also know that when the power of x overall in this expansion is 0, the coefficient will be 150. Well, we see if we rewrite this, so we have 4 choose r multiplied with k x to the power of 4 minus r, then we will have also 2 over x to the power of r. We have to see what r has to be such that the exponents of x cancel out. So here we have an x to the power of 4, and here we have an x to the power of r. So what we see is that if r is equal to 2, we will have x squared on the left and 1 over x squared on the right. So when we multiply them, the x's will cancel out. So we will have a coefficient of a term without x. We will have x to the power of 0. So what we have to say is that r is equal to 2. And so if r is equal to 2, we just have 4 choose 2 of kx squared multiplied with 2 over x squared. So this will simply simplify to, well, 4 choose 2 is going to be 6. We can also remember the definition, so there's just 4 factorial divided by 2 times 2. That's 6. And then the x's will cancel out, and then this has times k squared multiplied by 2 squared, so multiplied by 4. And we're told that this is equal to 150. So we just have to solve for k now. So we can say that k squared is going to be 150 over 24. If we divide that by 2, that's 75 over 12. We can still divide this, for example, by 3. So 75 divided by 3 is going to be 25 divided by 4. And we can still simplify this. So what we can say here is, and yeah, well, we can now just take the square root, and then we will find that k is equal to 5 over 4. So we only need to, 5 over 2, obviously. Square root of 4 is going to be 2. All right, so now we have the value of k, and we need to determine the coefficient of x squared. So again, we have to look back at this formula over here. And we will have x squared when r is equal to 3, right? Because when r is equal to 1, sorry. So when r is equal to 1, we will have x cubed over here, and we will have 1 over x over here. When we multiply them, we get x squared. So we say r is equal to 1. And so we have 4 choose 1. And then k is 5 over 2, x to the power of 3, multiplied with 2 over x to the power of 1. And then if we just simplify this now, we will see that this is just, well, a 4. 4 choose 1 is 4. And then when we raise 5 over 2 to the power of 3, so it's going to be 125 divided by 8 and multiplied by 2. And this will be multiplied with the x squared that will be cancelled out. And then we see that 4 times 2 is 8, so that cancels out with this. And so we just get 125x squared.